Today we're going to talk about volumes of cylinders. So cylinders, if you remember, these are three-dimensional shapes. As you can see from the picture here, we see the bases. There are two different bases that are circles, and then the space that goes in between them are completely filled. So kind of like a can would look. So when you look at the actual formula that we see in math world, the volume of a cylinder is this big B times H. Now, big B, as you can see up in here, is actually referring to the area of the entire base. So the base would be a circle. So if you think about the area of a circle, that really is what the big B represents. So it really is going to be pi r squared, which is the area of a circle. Then, because it's a three-dimensional shape, we would be multiplying the area of that base by the height to get the overall amount of stuff that could go inside or the volume of the cylinder. So big BH can get a little bit confusing versus like just little b times h. So the more specific formula that we're going to be using is if you look at volume for a cylinder, the big B would be pi r squared, that's the area of the base, the big B, times the height. So volume equals pi r squared h. That's basically the formula we're going to use for this. Okay, remembering that the height is the different distance between the two bases. So as you can see from that upper piece, we had this one is straight up and down, so the height is very easy to see. This one, notice how it's kind of tilted. This is not the height here. The height is always the perpendicular line that would come down to meet and join those two bases. So sometimes the height is off to the side if it's tilted a little bit. So let's just look at a few examples. Basically what you're doing is you're just plugging in the formula from what you see. You'll definitely be using a calculator, and then what you want to pay attention to is the problem looking for pi as 3.14? Is it looking for pi as the pi button on your calculator? Because those are two different kind of answers. And always looking to making sure that you are rounding correctly. So each problem is a little bit different. So this one says round to the nearest tenths. So what that means is basically we need to go out to the hundredths, because remember that would be the place value that would decide what's going to round up. So here we go. Find the volume. So we know the volume formula is just pi r squared h. Okay. Now this one doesn't say use 3.14. So this is one that maybe you use the pi button on your calculator. I'm just going to use 3.14 on this one because I think a lot of times that's what we end up using. So looking at the information I have, do I have the radius? Well, we do. The radius is going to be the 3 because we see that that is halfway across the circle. The height would be the 6. That's the distance between my two bases. So now we have the information. So basically we're just going to plug in for my information. And now use order of operations because I have everything I need. So thinking about order of operations, exponents will come before multiplication. So just make sure we don't make a silly mistake here and say 3.14 times 3 and then square it and then times 6. Order of operations says do your exponents first. So by doing my exponents first, I get 3.14 times 9, remember 3 squared is 9, times 6. Now this is all multiplication. So if I just use my calculator, I can do 3.14 times 9 times 6, and I get volume equals 169.56. Now again, this problem says to round to the nearest tenths. So remember, we go to the hundredths column to decide. The hundredths column, if it's 5 or greater, would then say round up the number in the tenths. So my answer means that the 5 becomes a 6. And then we always want to make sure that we have a label. So in volume, we always do cubic measurements. So in this case, we're dealing with meters, and it is to the third, or cubic meters, so 169.6 cubic meters. Moving on to the next one. So again, on this one, a couple things you want to notice. We're just finding the height. So this time, we're now given some information that we're going to work backwards from, which goes back to our problem solving from the beginning of the year. We're basically going to plug in our information as we go. So let's just go to our formula. So volume pi r squared h, and let's plug in what we have to decide what we need to solve. So volume, do we have the volume? We do. 314 cubic inches. Pi, let's use 3.14 again. Do we have the radius? Well, remember, in my radius, I do have the radius if I do a little bit of work. So this 10 is referring to the diameter, which is all the way across. So we know that the diameter becomes the radius by dividing by 2. So my radius is a 5. And do I have a height? No. This time we don't know the distance between the two circle bases, which is what we're trying to solve for. Just interesting here, just make sure you don't make the mistakes of saying that 10 is my height because we think of height as up and down. The height is always the distance between my circles. So because this one is kind of laying on its side, the height is how far apart the two bases are. So just make sure you don't kind of fall into that trap. So we go back to our problem. We have this all filled in now. So the 314 can stay there for now. 3.14 is going to stay first. 5 squared is the first thing that we would do. And then we have the h. So now we're just kind of solving an equation for that variable. We know that that means we need to get everything on the isolating the h. So if I put 3.14 times 25, I get 78.75h equals 3.14. I undo 78.75 times h by dividing on both sides by 78.75, and then those will cancel, leaving me h equals 3.987, and it keeps going. Now, at the beginning of this problem, it says to round to the nearest whole number. So rounding to the nearest whole number in this case, we would use the tenths column to decide. If it's 5 or higher, we're going to round up into the ones. So that means our height is 4, and in this case, the height is going to be only in inches because that's a single dimension. It's not the volume, which would be cubic inches. Okay, next. Here we have one of those cylinders that's kind of tilted off to the side a little bit. So we just want to pay attention to what that means. So again, we're just filling in the formula. So the biggest thing about this thing, filling in the formula, notice that it says round to the nearest whole number, pi r squared h. Do we have the volume? We do, 226. We're going to continue to use 3.14 for their pi. The radius, do we have that radius? No. So that's going to be the one that we're searching for. And then do we have the height? The height is an 8. So in this case, what I first need to do is put together the things on the right-hand side. So if you think we can rearrange this a little bit, I can do 3.14 times 8, which gives me 25.12 r squared equals 226. Again, I'm now going to do 226 divided by 25.12, because to undo that, I would do the multiplication first, which is really division because we're doing the inverse. That will cancel there to give me r squared. And on the other side, this is going to give me approximately 9. It's a little bit under, it's 8.9968. I'm going to make it 9. Then remember to undo a square. We talked about this in the last chapter. We take the square root. Now, when we take the square root, there are two answers. The square root of 9 is 3, but it's also, remember, negative 3. However, can I have a radius of negative 3? No. So if I just said what's the square root of 9, I need to consider both 3 and negative 3. But in this situation, I can't possibly get a negative 3 for a side. So in this case, we throw away the negative 1, and our answer is going to be 3 feet. Okay, and then last problem here, we have a situation where we see this barrel. We can see this would be our height right here, the distance between our two bases. We have a distance across the entire barrel, which is going to be 1.8, which we've got to think about. Is that really what we need for our formula or not? And then we're going to try to figure out how many gallons does the barrel hold. So based on the size of the barrel, once we have that, we're going to use the volume, which will be this cubic feet, and understand that there's 7.5 gallons for every 1 cubic foot. So step 1. So using the formula, we're going to fill in pi r squared h. Since the diameter is 1.8, that means the radius, which is half of the diameter, is 0.9. Then we're going to plug in for the r and 2.3 for the h. The r, we just decided, was 0.9, and we're going to solve for the cylinder. So the volume, 3.14, the r was 0.9 squared, the h is 2.3. So then we have everything on that one side that we need. Remember, we do the square first. So that's going to give me 0.81 times 3.14 times 2.3, which is 5.85. It's about 5.84982, so I'm just going to round it to about 5.85. So remember, this is the volume. So this would be feet cubed. This time they're not asking for the volume. We need the volume, but we're not asking that for the final answer. What we want to do is figure out how many gallons. So step 4 is let's use a proportion. So there's other ways to do this, but let's use the proportion. So in my proportion, I'm going to set this one up as 1 cubic feet as compares to 7.5 gallons. Now you remember a proportion is 2 equal ratios. So on the other side, I need to follow the same procedure here. So I had cubic feet above gallons. So on the other side, I need to put my cubic feet above the gallons. So on the other side, I would have 5.85 over x gallons. So I don't know what that is. That's going to be the one that we're missing. So remember, with your proportions, you are going to use your cross products. So proportions will say, I'm going to multiply my numerator times the opposite denominator. So 1 times x, I don't need the labels while I do this, is just 1x. Then I do 7.5 times the 5.85, and I get 43.875. And now we have solved for gallons. Now this time they don't tell us what they want us to round to, so we're just going to say that it's approximately 43.875 gallons. If you had 44 gallons, that's pretty close also. But that's just a couple of quick examples. The volume of cylinders is pretty simple. Just make sure that you use the correct formula, V equals pi r squared h, plug in your information correctly, follow your order of operations correctly, and just make sure that you are being careful with your rounding, including your labels. Hopefully this will help. If not, please feel free to ask any kind of questions.